vehicle, and it came in 3 different models and 5 different colors, and so we took 3 and we multiplied it by 5 and we got 15 different types, correct? Then we went down to the bottom of the page and I said, hey, it can be in an SE or an LE version. So we took those 15 and we times it by 2 and we got 30, because you can just keep adding on more things as long as you're only picking one of each type. Now, here was where we talked about the robot. We talked about the top being red or blue. We talked about the middle being orange, white, or black. We talked about the bottom being purple or pink. So we took 2 for the top times 3 for the middle times 2 for the bottom, and we got 12 different robots, correct? Because we had to have one of each of these, and we had to take all 3 parts to make the robot. So that's kind of what we went through so far. Now we're down to here. We're at how many odd 4-digit numbers are there? Now, we're using all the brain cells. Ready? So all the brain cells means none of the phones, all the brain cells. I am going to ask you if these numbers are odd or even, and you are going to tell me if they are. Ready? 4. Even. Good. More of you can answer, because I know you knew more of you knew that was even. 17. Okay. 152. Okay. That seems easy. 1,764,503. Okay. Showing off. All right. Okay. 700 bajillion, 765 billion. I don't know what's above the 2 billion, million. 397,543,601. What are you only listening to? The last number. I could be like 907, and you'd be like odd. I can say whatever I want before, it don't matter. We agree? So when it says here how many odd 4-digit numbers there are, what are we saying? The last digit has to be an odd number. We agree? And 4 digits means how many numbers are there? There's 4. So I have 1 blank for the first digit, 2nd digit, 3rd digit, 4th digit. And then because it has to be odd, this has to be 1, 3, 5, 7, or 9. Now this unit is completely new. There is no overlap of anything that you've ever learned before. So if there were to be a time when you were paying 177% attention, which you can only pay 100, but I want more, this would be your time. Okay? This is a unit that scared me in high school because I didn't truly understand it. So I've made it my goal to make you all understand it. There's got to be a better way. Okay? So 4 digits means 4 blanks. Do you agree? Like 1,000 is a 4-digit number because it's a 1, a 0, a 0, a 0. We agree? Now what if I say to you, I'm going to pay you in a 4-digit number. Ready? I'm going to pay you 4,739. Did I pay you in a 4-digit number? Yep. Okay, I'm going to pay you in a different 4-digit number. Ready? 0653. Is that a 4-digit number? No, I just paid you in $653. I paid you in a 3-digit number disguised as a 4-digit number because the 0 in front of the number doesn't actually make it be a bigger number, does it? Now, if I wanted a 4-digit code, could I go 0653? Yes, because that's a code. A code could be 0000. People are breaking into your bank account, but you could use it, right? So if it's a code, you can start with 0, but if it's a number, you can't. So odd here, I would write myself a little note. Odd means the last digit needs to be odd. And then a 4-digit number means 4 blanks. And the first blank can't be what? Yeah. First blank can't be 0. They're not going to say it's a 4-digit number, the first blank can't be 0. They're not going to be that nice. They're going to say 4-digit number, and you're going to need to know that the first blank can't be 0. Now, the reason why we can use the fundamental counting principle is we're picking one number to go in each blank, correct? And I need every single blank to make the 4-digit number. So I need this blank, and this blank, and this blank, and this blank. And remember when I said when I use the word and, I multiply? We said this before, but we're going to reiterate it. It's been a little bit. But when we use the word or, we do what? You remember? Very close to and. We add. Because and add, I told you, look very similar, but they don't actually go together. Or you'll add, and you multiply. So I need this digit, and this one, and this one, and this one, so I have to put the multiplication dots. If you're someone who doesn't have the multiplication dots, put the multiplication dots. Because if you don't have the multiplication, you're not showing the operations that you're actually doing, and you won't get the marks. Okay? So we always have to start with restrictions first. So I'm going to start with this back one. So here says I am taking one number. This blank means I'm putting one thing here. Above it says how many of the one things I can put in here. So how many objects or digits can I put in here? 1, 3, 5, 7, or 9. How many is that? That's 5. So I'm putting a 5 up here. So the number that goes above is the options. Just like when we had purple and green, we put a 2, because that was the options we had, right? When we had yellow, green, and orange, we put a 3, because we had 3 options. Here we could put a 1, 3, 5, 7, or 9. We could put 5 options. We are only keeping one number there, but we can have 5 options. Okay? Now the first one I told you, we have to go to this one next, because we always have to deal with restrictions first. This can't be a 0, but it can be the numbers 1 to 9, which are how many options? 9. Was there any restrictions on the middle numbers? No. The only catch is that they have to be one-digit numbers, because if it's a two-digit number like 12, that's actually a 1 and a 2, and it would take more than one blank to fill that in, right? So we can only fill one-digit numbers in these blanks. The one-digit numbers are 0 to 9, correct? There's no restrictions on these middle ones. The back is odd because it has to be odd. The front can't be 0 because it has to be 4 digits, but there's nothing in the middle. So these can be 0 to 9. And how many numbers is 0 to 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many is that? 10. 0 to 9 is 10. And I would honestly rather people count it on their hands and get 10 than count it in their head and get 9, because 9's wrong. Okay? And it happens all the time. It will. 0 to 9, you guys, at first, lots of people say 9. You'll say 10 from now on. But when it's like 1 to 6, people will get that wrong. And 1 to 6, because they'll say it's 6. Or they'll say it's 5, sorry. 1, 2, 3, 4, 5, 6. 1 to 6 is actually 6, because you're including the 1 and the 6, right? So I'm not joking. I would rather you count it on your fingers and get the number right, because people will get it wrong all the time. It's just sad. So now we multiply these out. We get 9 times 10 times 10 times 5 is 4,500. So there are 4,500 odd 4-digit numbers in this world. Okay? The next one says, how many odd 4-digit numbers are there? That sounds very similar to the previous one. With no repetition. No repetition. That means you can't have like 1, 7, 6, 1. Like you can't have 1 twice. You can't have a 2 twice. You can't have 2 3 times, right? You can only have each number once. Okay? So we still set it up the same. We have our 4 blanks. This one still has to be 1, 3, 5, 7, or 9. That's not a difference. This one can't be a 0. We know that. Now, if every single time you have no repetition, you box and hold, your life will be better. So this is what I do every single time. I box and hold numbers when I can't repeat. Because you're going to pretend to keep a number there so that you can't reuse it in a different spot. Now everyone should be copying this down because it's not for my welfare, it's for your notes. It's crazy how that works. Now, the back number we're going to deal with first because it's restricted. How many options do we have there? Still 5, correct? Hasn't changed. But now I have to pretend to keep one of those numbers because I can't reuse it again. I'm not allowed to repeat, correct? So you could box and hold the 1, the 3, the 5, the 7, or the 9. It doesn't matter. You just can't use it later. So I'm going to pick the 9 just because it's on the edge and I'm kind of lazy. So I'm going to go boom. I'm going to pretend that I'm keeping the 9 there. So in the last example, I had 1 to 9 as my first options because I couldn't have 0, correct? But now I can't have 0 because it would make it a 3-digit number, but I also can't have 9 because I pretended to hold it. Now, if you had held 1, you wouldn't be able to have 1. 3, you wouldn't be able to have 3. Like, it doesn't matter which one you pick, you just can't have it in the next one, right? So what options do I have now? 1 to 8. Which is how many? 8. Now I'm going to pretend to hold the 8. So now I have 1 to 7, which people will tell me is 7. That is not an incorrect statement. 1 to 7 is 7, but 7 is not the answer to that blank. What options do we have? We have 1 to 7, which is true, but what do we have to remember to bring back that we have never used yet because we couldn't? Oh. I hear someone whispering it. Say the number. 0. Yeah. Katrina was saying 0. He was not saying what you were saying, but that's okay. You're right. It's a 0. So we pretended we held 9 at the back, correct? Then we held 8 at the front, correct? We had to bring 0 back because we couldn't use 0 in this one. It's not used up, but we just didn't have it as an option. We couldn't use 0 here, correct? Because it wasn't an option. So we have to remember that we can actually use it here, and we have to bring it back. So the answer on a test, people will go 8 times 7 times 6 times 5. That answer is picked more than the correct one. That is not correct. Because it's 8 and then 8, because we have to remember to bring the 0 back. And if you're like, yeah, dude, I would have never remembered to do that. That's when you leave yourself a little side note with a star. And you'd say, remember, and you know if that would have been something you would have thought of, remember to bring the 0 back in the second blank. So now we have 1 to 7 left, and so we have 7. And remember, multiplication dots, because you need each of these blanks to make the whole number. You need the first, second, and third, and fourth. Now, a plug for the calculators. If you still don't have one of these, you need to get one. If you're someone who thinks you're making it through the whole semester without one, you're not. I'm sorry to burst your bubble. We're going to be using the P's and the C's in a couple days here, where you actually can't do it without this calculator. And then we're going to be doing regressions, which you can't do without this calculator. So you're sadly going to need one. So if you don't have one, you're going to have to find one. Like I said, get your parents to go on to like Facebook garage sale and ask for them. You get them for like $60. So we have 2240 when you multiply them out. All right. So example 4, we have car number plates in an African country consist of a letter other than I or O. Okay, that's the first thing. Consist of a letter other than I or O. So they're given a letter. Can't be I or O. Okay, I got the first blank. Let me keep reading. Now, some people are like, oh, word problems. I hate word problems. About 75% of your curriculum is word problems. So you might as well start adapting to being okay with them. Like, you're going to have to come to terms with it. There is a ton of reading in 30-2. There just is. Okay? So we went from set theory, which was reading, to perms and coms, which is reading. Then we're going to go to rationals, which isn't as much reading. So only one. There's one word problem in it. Then polynomials, which is a bit of graphs, and then a whole bunch of word problems about the graphs. So reading. And then we're going to go to logs and exponentials, which is your solving, plus word problems, which is reading. Then we're going to go to probability, which is reading. So when you're like, I hate word problems, I just won't do those, that will not go well in this year at all. Okay? Trust me, people do really well in this course. So it's the faster you say, you know what, I can do these, and I'll just read through it and I'll highlight and underline, the better off you'll be. Because you're going to get to that point. I just hope for you get there sooner than later. Okay? So here we have car number plates in an African country consists of a letter other than I or O. Here's a letter. It can't be I or O. Boom. Did my one blank. Moving on. Followed by 3 digits. 3 digits gives me how many blanks, guys? 3. So we get digit, digit, digit. Then we keep reading. The first of which cannot be 0. So I go here and I say no 0. And then these just have nothing about them, so they can be any number, right? When they don't say anything like they can't be restricted, this would be 0 to 9, 0 to 9. We know that. So I'm going to help myself out. I'm going to say 0 to 9, 0 to 9. Okay? Then followed by any two letters which are not repeated. And it means not repeated either of them. So not repeated means just the two of them aren't repeated, right? So if this one is A to Z, when I say not repeat, what do I tell you you're supposed to do? Box and hold. So I have to box and hold something from there, right? So I'm going to box and hold the Z, and now I have A to Y. So we have specified things about each of them, correct? If you take the time to spend the time to write the stuff, life will be easier. The people who are like, I just draw a random blank, put an answer down, put stuff in my calculator, those people never do well. Don't be those people, okay? Show the work. So here, I'm going to go to the restricted ones first. So this one's restricted. It can't be I or O. How many letters are in the alphabet? 26. Now keep this in mind. A, E, I, O, and U are all vowels. A, E, I, O, and U are all vowels. If you're like, I've never been good at that, and you're not going to admit it, because that's where you are at, that's fine. Get to the top of your page and admit it to yourself. Write down A, E, I, O, U. Because you know what's worse than you not knowing that? Is you not admitting it and getting every question wrong because you don't know what the vowels are. That is worse. What's better is you say, you know what, Lepp? I don't know them, but I'm going to study them. That is the better place to be. Here you are. There are 5 of them. In the English language, there is sometimes Y. In the math language, we do not worry about the sometimes Y, because the sometimes Y only comes in when you have all consonants and the Y is received as the vowel in the word, because there are no other vowels. We don't go through and check through Scrabble if it's a real word. Like, man, that's not real. We don't care. We just care that it looks different than the other one. It could be eep, or it could be eepoo. It's like it doesn't matter. We don't care if it's a real word. We care that it just looks different. So Y's are never vowels. So this is a vowel. There are 5 of them. The other thing is called this. This is people actually don't know. A consonant. A consonant are the 21 other letters. Most people are good with vowels, but they rarely hear consonants and then don't really know what it is. Okay? So consonant are the other letters. If you're someone who does not know the vowels, please write them down and start memorizing. Because vowels come up a lot. Okay? I don't care what you do or do not know. I care what you come out of here knowing. So start learning it now. It doesn't matter to me if you didn't know it. So we have A, E, I, O, U are the 5 vowels, 21 consonants. We agree? Okay. We go back down here. So we have I or O, can't be in there. So how many letters do we have left? If there's 26 in total. We have 24. Okay? We know that this can't be the number 0, so it can be the numbers 1 to 9. How many is that? 9. 0 to 9 is how many? 10. 0 to 9 is how many? 10. A to Z is how many? 26. A to Y is how many? 25. Now, if you actually write the stuff below the blanks, you've gotten rid of the hard work, right? Putting the numbers above is easy now if you actually take the time to fill in the bottom. Now, what did I tell you have to do? You have to make sure you have multiplication dots. So if you're someone who's not doing that, do it. I had someone in the other class, even after repeating this 700 times, that said, are you really going to take off marks if I don't put the dots? Yes. Yes, I am. I'm saying it now. It will happen. Because you're not showing your operations. If you don't have the dots, you actually have a number that's just 24910102625. That's your number. If you don't have dots, you just have numbers that are weirdly separated. That's all you have. So we type it in, we get 24 times 9 times 10 times 10 times 26 times 25, and we get 14,000,000 40,000. Now, the saddest thing ever is students who won't answer questions because they're scared to say big numbers. That's the saddest day in my life. So, I'm going to remind you why this is not that bad. Because, and I reminded my daughter of this in grade 6, who said that she's mad because they have to do the billions this year, and grade 6 curriculum last year didn't have to do the billions, but it's new curriculum, and now they have to do billions. I'm like, can you say a 3-digit number? She said yes. I said, then you can say billions. It doesn't matter. Because all you're saying is 3-digit numbers with words behind them. Placeholders. So they're either in the billions, they're in the millions, they're in the thousands, they're in just a 3-digit number, correct? That's all it is. So if I go to say this one, I'm going to put commas in to help me. I break it into 3-digit numbers. Ready? I expect all of you to be able to say numbers because it's not that hard and I believe in you. Okay? So here's my first 3-digit number. It happens to be a 2-digit number, but it doesn't matter. What is this number? It's 14. What spot is it in? It's in the millions. Boom. Okay? What is this weird number? 040. It's 40 with a 0 in it. It's in the what? The thousands. And then this is just silent. Right? So what do you have? You have 14 million 40,000. That's it. That's all numbers are. So say you're given this. This is what number? 13, and it's in the billions. This is what 3-digit number? 897, and it's in the, what number is this? 10, it's in the, and what's this number? Yeah, so this is 13,897,010,007. That's all the number is. It's like built up so badly in elementary that these are really hard. But remember, your brains were lower and then you didn't know as much stuff. So this might seem ridiculously easy now because it actually isn't too bad. Right? It's like learning grade 10 stuff in grade 12. If you go back and learn your grade 10 stuff, you'd be like, what was that? And you thought it was really hard in grade 10. Okay? You should never be not answering questions to me because you're scared to say the number. You should be, like, just keep in mind it's just 3-digit numbers with words behind them. I'll even accept 1793820017. I'll take that if someone will answer for me. It doesn't have to be in perfect word form. Okay? Because some of these get to be really big numbers. So we're going to look at example 5. Example 5 says, the telephone numbers allocated to subscribers in a rural area consists of one of the following. Are you ready? Now tell your brain I can do this. Because you might want to quit at this point because it's words. And if you were me in high school, I wanted to. I hated word problems. So I feel your pain. But we have to overcome. So we're going to keep reading. We have the digits. 3, 4, 5. What does that mean? That means we have the digits 3, 4, 5. 3, 4, 5. We're listing them underneath. We always list the options underneath. Ready? We have the digit 3, 4, 5. Followed by any 3 further digits. Digit, digit, digit. What can they be? 0 to 9. Because there was nothing on them about restrictions. Or. Oh my goodness, we have the big word or. We have cases. We have case 1 or case 2. When we have or what do we use? What operation? Add. Because and we multiply or we add. So we always add our cases. So we're going to do this plus, now let's discuss the next one. The digit 2, followed by one of the digits 1 to 5, followed by one of the digits 1 to 5, followed by any 3 further digits. Digit, digit, digit. Is there anything specified about those digits? No, so what can they be? 0 to 9. Before I go to do the numbers, I'm going to make Mrs. Lepp happy, and I'm going to go put some multiplication dots in between here because she needs those. So do people marking on the diploma. Everyone needs them. Shows what operator you're doing. You're multiplying all those and then adding the middle. All right. We did the hard work. Let's do the easier part now. How many 3s? How many digits are here? 1. Okay, what about this one? 1. What about this one? What about 0 to 9? 0 to 9. 0 to 9. 10. 1 times 1 times 1 is 1 with 3 zeros. Remember when you multiply by a 10, you just get more zeros? So this is 1,000. Plus. How many digits in this first blank here? 1. 1 to 5 is how many? 0 to 9 is how many? 10, 10, 10. 1 times 5 is 5. 0, 0, 0. So it's 5,000. And we add them up, and we get 6,000. Okay. We have the word. Look in here. It says, consider the number of distinguishable. Distinguishable means different looking. Okay? So ready? If I give you pool, then I swap the 2 O's and I give you pool, can you tell the difference? No, those would not be distinguishable, right? If I go switch the O's. But if I give you peel, P-E-E-L, and then I give you eepel, E-P-E-L, I'm not giving you to look up the Scrabble like words, like, is it real? Like, like, what is this? No, I don't really care. I care that they're distinguishable. It just means looks different. So they'll always say distinguishable. Don't let that word throw you off. It just means looks different. And you're always going to find ones that look different. So you're always going to do what they're asking you to do, even though that might throw you off. Okay, so don't let the word distinguishable throw you off. So we want to consider the distinguishable 4-letter arrangements. We have to watch. We only want 4 letters. That can be formed from the word English. Now, how do we know we can't repeat? Well, it'll say you can't repeat. If it doesn't say that, you assume you can. Unless you're the word English. Ready? Here's English. I have an E. I have an N somewhere in this file. An N. Yep. Then I have a G, an L, an I, an S, and an H. Okay? Right here. Boom, boom. This is what I got to work with. See this? People are like, do I have endless number of E's? Do I have endless number of E's? This is the question. Do I? Nah, I got 1. I got an N, I got a G, an L, an I, an S, and H. Ask me if I got a C. Do I have a C? No, I have an E, an N, a G, an L, an I, an S, and H. They will never say that you can't repeat because this is all you got. If you put one of these down in the first blank, do you still have, English has 7 letters. If you put one of these letters down in the first blank, do you still have 7 letters for the second blank? No. Look, I put one down for the first blank. How many do I have for the second blank? 6. Wow. Put one down for the second blank. Now how many do I have? 5 then. I drop one for the third. How many do I have? And then, it didn't work as well as I planned. How many do I have for the last blank? 3, right? So you are getting rid of one every single time because you only have 7 letters sitting in front of you. When you put one down, you're done. She's sitting there. Okay? So you treat them like whenever it's a word, you treat it as a box and hold because you're going to leave a letter there. We agree? So the first one wants distinguishable 4-letter arrangements of English if any letter can be in any position. So 1, 2, 3, I need 4-letter words, so I'm going to need 4 blanks. Each blank holds a letter, just like each blank held a digit, right? 1 letter in each blank. We agree? So I'm going to show this. After, you're probably not going to have to do this, but I'm going to show it to prove a point. So for the first one, I have an E, an N, a G, an L, an I, an S, and H. I showed you that. I was holding them in my hands. Correct? So I have 7 options. But then I'm left behind an E here. Could I leave behind an N, a G, an L, an I, an S, and H? I could leave behind any of these, correct? It just means that for the next one, I can't state that letter. So now I have N, G, L, I, S, H. So now I have 6. Say I keep the H. And I have N, G, L, I, S, which is 5. Keep the S. Then I have N, G, L, I, which is 4. And then I multiply that. So there are 840 different distinguishable words that I can make out of English. 4-letter distinguishable words, I can make 840 ones that look different. Okay? I want you guys to try B and C on your own. C. B starts with an E. C is vowels, but the vowels have to be contained in the word English. So what vowels are in English? An E and an I. There are 2 of them. Okay? Can't use and like they're not in English. So you can only use the ones. So try B and C. So for this one, it's distinctly still a 4-letter word, so I have to do 4 blanks with dots in between. The only catch here is the first letter must be an E. So if I actually had 2 E's, I would put a 2 here, because I would have 2 E's that I could put in there. And we get rid of the cases where they look the same later. But we're not doing doubling, tripling letters till 2 lessons from now anyways. But if there happened to be like Peel, P-E-E-L, I would put a 2 there, because I would have 2 E's to choose from. I'd have an E and an E, correct? But I only have 1 E in English. So I box and hold it, and I only have 1. So I put a 1 there. Now, I boxed and held it. I have I have an E sitting in the front. So I can't use it for any of the rest of the 3, correct? So I can go to any of these, but I always go from left to right if I have a choice. So E's out, N-G-L-I-S-H gets me 6. Say I keep the H. Then it's N-G-L-I-S, which is 5. Keep the S. Then I have N-G-L-I, which is 4. So you get 120. So we're going to look at C. C says the first and last letters must be vowels. The only vowels in English are E and I. Those are my only 2 options I have. Okay? But I know that the first and last letter needs to be vowels. So I go to the first blank and I say, okay, well, it has to be a vowel, so I only have 2 options. I have E or I have I. Those are the only 2. If I put N, G, L, S, or H in there, it's not a vowel. I'm not following the rules. Okay? So I have 2, and then say I have to box and hold something, so I'm going to box and hold the E. Well, what do I only have for an option now? 1, and it's the I. So I box and hold that. So could I have vowels in the middle? Sure, I could. In this case, can I have vowels? No, I just used the 2 vowels up. I literally can't put them in the middle. But just because they said it's on the outside doesn't mean I couldn't put them in the middle. If I had a 3rd vowel, it could go in the middle, correct? Then I would have 3, 2, and I'd start over. But I only have 2 vowels, so I use them up. So now I use up the E and the I. So I have N, G, L, S, H left. So I have 5 for this one. Say I hold the H. Then I would have 4 for this one. So now I'm down to 40 options of distinct different 4-letter words. So the 4-letter words out of English, total maximum are 840. When I restrict the first one letter to be an E, I can only come up with 120 different words. It got smaller, which makes sense. Then when I really restricted it to the first and the last of the 4 have to be vowels, I really knocked myself down to only 40 different words. Because it does. It should restrict you down to less words, right? Because you're giving less options for those blanks. The last one said the word must contain a G, but does it tell you where the G needs to be? No. So the G could be in the first. Okay? There's only 1 G, so we either have it in the first blank, or, which means we add, because the moment we get a new case, we add our cases. So we could have a G in the first blank, or we could have a G in the second blank, or we could have a G in the third blank, or we could have a G in the fourth. Now we do each case separately. So if I have a G in the first blank, I have 1 option. I hold the G here. Then I have E, N, L, I, S, H. So how many letters do I have for this one? 6. Then I hold 1, so I have 5. Then I hold 1, so I have 4. What's going to happen in the next line? I get all my letters back. It's still going to be the same numbers, just out of order, right? Because I'm going to start with the G first, which gives me 1 option. Then how many letters do I have left for this one? 6, then 5, then 4. Here I have 1 option, hold it. 6, 5, 4. Here I have 1 option, I hold the G. 6, 5, 4. So this is 120 times 4, which is 480. Then we're going to flip over. I'm still shocked that people don't write out all the notes when, like, 2 of your assignments are open book. But that's your choice. Okay. Your turn. You're going to try the A, the B, and the diploma practice questions. So you're going to go all the way to the word script. This script question, you're going to go all the way to here. So you're going to try them all on your own right now from your turn. You can discuss with someone around you. I don't care about that, but we're just going to try it out. If you need help, call me over. So here we have a luggage lock opens with the correct 3-digit code. So we have a 3-digit code. Boom, boom, boom. Each wheel rotates 0 to 9. How many different 3-digit codes are possible? So we need 0 to 9, 0 to 9, 0 to 9, and it's 10, 10, 10, and we get 1,000. The next one says, suppose each digit can only be used once. How many different codes are possible if repetition is not allowed? So now we just box and hold. So we get 0 to 9, which is 10. Now the reason why we can have 0 to 9 is this isn't a digit number, it's a code. A code can start with a 0. The only thing that can't start with a 0 is a digit number. 3-digit number, 2-digit number, 5-digit number. So we have 0 to 9, then say I hold the 0, then I have 1 to 9, which is 9, say I hold the 1, then I have 2 to 9, which is 8, and that's 720. The next one says, an Alberta license plate has 3 letters, boom, 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 letter, 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 followed by 3 digits, boom, 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 digit, digit, digit. The letters I and O are not used to avoid confusion with the digits 1 and 0. So I and O are out completely for everything, anywhere in here. Well, letters are the first 3. So I and O are out for the first 3. So how many do I have for the first blank? 24. Does it say I can't repeat anywhere in here? No, so I assume I can, because the only time I can't repeat is it has to say cannot repeat, unless it's a word. So 24, 24, 24. And then what do I have for these ones? 0 to 9. Yeah, so 10, 10, 10, 10. So it's going to be 13,824,000. Which sounds like a lot. But the problem is that they keep license plates. Sometimes they don't give them back. You run out of license plates. Yep. No addition sign, sorry? Oh, because it's going to be multiplication, because you're not doing 3 letters or 3 numbers. You're doing 3 letters and 3 numbers makes a license plate. Yeah, so when you use and, it's multiplication. If your license plate could be 3, if your license plate could be 3 digits or 3 letters, then you would have a plus sign in between them. So because of the growing number of vehicles, Alberta did this, the province is changing to plates with 3 letters followed by 4 digits. Adding another digit adds a 10, correct? When you add a 10, you add a 0, which doesn't sound like much, but you're actually adding a 0 placeholder, right? So we would actually get 24 times 24 times 24 times 10 times 10 times 10 times 10. Now instead of 13 million, it's going to be 138,240,000. So it gets you another placeholder. So it gets you to 138 million. That's more than 100 million more, right? So it makes a big difference. If they wanted to make a bigger difference, they could have multiplied it by, they could have made it be 4 letters instead of 4 digits, because then you'd multiply by 24 instead of 10. There are too many people on phones. Off your phones. Okay. So we have Sally wants to decorate one wall in her room. Here's the wall. I have it up here. Look how pretty it is. So here is her room. She wants to decorate it. I have 8 posters that I've drawn with my heart up here. Okay? She has 8 posters to choose from. It's just like if you went home and you had, you went up to your wall and you had, I don't know, pictures of your family, and you could put 4 up out of the 8, whatever, 5 up out of the 8. So here it says that she puts her favorite poster in the middle. So I'm going to put the pig in the middle that people thought was a dog and a cat. It's totally fine. I won't take it personally. So the pig is in the middle. It's funny because 3 people did this and everyone thought it was a dog or a cat. So it's not just you. It might be the pointy ears on the pig. So we choose our favorite poster for the middle. How many options of posters then for that one? We have 1 in the middle. We agree? I'll draw it on there after. Okay, good. 1 is done. How many options do I still have left? Please pay attention. How many options do I still have left for this one here? I have 7. Look, they're sitting here. I have so many options, so little time. So I have 7. Shoot. I decide to pick the birthday cake. It went in the first one. Now how many options do I have for the second blank? 6. I decide to put the sad face because so many phones are in and people aren't paying attention to me. And then this one we have 5 and I put the cube. And then this one is 4 and I put the tree. You know your child, this is an aside, you know your child is a math teacher has a math teacher mom when she gives me crap. She's like talking about a ball and I'm like, yeah, go get, it's a circle. She's like, actually, it's a sphere. I was like, true that. I was like annoyed and slightly proud all in one. I was like, yeah, that's a 3D shape. You are right, sister. Yeah. So she hates math but knows a sphere. Come on. Okay. So we multiply these. We have 7, 6, 1 in the middle, 5, 4. And then we have 3 posters that we can put in our closet to take out at a later date and put on our wall if we need, right? So we multiply that, we get 840. All right. This one is confusing. Now remember, you guys are just learning these. So they are confusing at first, but you practice enough of them, you see little patterns, and you figure out what you need to do. When you need to do pluses, when you need to do multiplications. And I just said pluses. Yep. So we are going to use this every single day in daily quizzes and practice questions, right? I don't expect you to understand it perfectly right now. All right. I do expect full attention. So here we have from 1951 to 1981, the first digit of every 3-digit telephone code in North America was 2 to 9. So that was the first digit. Inclusive means including the 2 and the 9. The second digit was either 0 or 1, and the last digit depended on the following rules. Okay, there's 2 rules here. When they give you more than 1 rule, it often means more than 1 case, just so you know. When we have cases, we're going to show 1 case, or, which means plus another case. When there's more cases, meaning you don't just finish it with 3 blanks and you're done, they're going to often, if it's a case, they will be added, because it's I either have this case or plus sign this case. Correct? And or means I add. So this one says, if the second digit is a 0, I do this. If the second digit is a 1, I do this. So I have to do 2 cases where the second digit is a 0 or the second digit is a 1. So I'm going to get 1, 2, 3, or 1, 2, 3. We're going to multiply these ones. Cases aren't because it's adding, because it's or. I have to do a case where this is a 0 or a case where this is a 1. It doesn't change my first digit. It's still 2 to 9. That doesn't change. But the back digit does change. So I have to do it in cases. Okay? So I look at the first case. 2 to 9 is how many numbers? How many digits? 2 to 9? It's 8. People will say 7. Trust me. Use your fingers. 2, 3, 4, 5, 6, 7, 8, 9. It's 8 digits. If I pick a 0, how many digits is here? 1. It doesn't say I can't repeat. It says I can actually here. Now, if my second digit is a 0, the last digit can be 1 to 9. How many options is that? 1 to 9 is how many? 9. 8 times 1 times 9 is 72. Plus 2 to 9 is 8. A 1 is 1. And then it says if the last digit is a 1, or if the middle digit is a 1, the last digit is 2 to 9, which is how many? 8. So it's going to be 72 plus 64, which is 136. Then we're going to flip over. Now we have the word script. Script, Scrabble tiles. I have an S, I have a C, I have an R, I have an I, and I have a P, and I have a T. I have 6 letters, correct? I can't repeat because I have an S, a C, an R, an I, a P. So I for sure am boxing and holding because if I use up the S, it's gone. I've used it up. We want distinct 4-letter arrangements. It doesn't say it has to start or end with anything. So I actually have S, C, R, I, P, T here. So I have 6. Then say I keep the T here, I no longer can use it. It's a Scrabble tile. I left it there. Now I have how many for this one? 5. I have S, C, R, I, P. Then say I keep the P, then I have 4. Then I have 3. So it's 120 times 3, which is 360. We're doing this last one here. 5-digit, odd number without repetition. Go, quickly. 5-digit, we did a 3. Well, actually, we did 4. Now you're doing a 5. Try it out. See if you don't mess up. 5-digit means can't start with a 0. Odd number means it has to end with an odd.